Algebra 2, Chapter 7, Section 1, Roots and Radical Expressions. In this lesson, we're going to learn about the nth root, the radicand, the index, and principal root. Okay? So first, let's make sure we're all talking the same language. So let's talk about this. Since 5 squared equals 25, we can say 5 is a square root of 25. Since 5 to the third power of 5 cubed equals 125, 5 is a cube root of 125. Since 5 to the fourth power is 625, we can say 5 is a fourth root of 625. And since 5 to the fifth power equals 3,125, we can say 5 is a fifth root. Okay. Notice the order of what we're going here. This pattern leads to the definition of what an nth root is. For any real number, a and b, and any positive integer n, if a to the nth power equals b, then a is an nth root of b. Okay, now that we've talked about our language, let's talk about something that we've used in the past. Okay, if I asked you right now to say what that was out loud, you would say that is the square root of 3. And if I said, what is this thing, you might not know. So let's kind of talk about what everything means. So looking at the diagram in the upper right hand corner, all right, we have an index. That's a little number to the upper left hand corner. The thing that the square root sign is called the radical sign. And anything underneath is called the radicand. Okay? So when I did this, and you guys told me that was a square root of 3, notice there's no index. It is automatically assumed the index is 2 on a square root sign. Okay? So that's important to know because we're going to use that index here in a little bit to explain our roots. Remember our cubed root and our fourth root. Okay, so read on. When a number has 2 real roots, the positive root is called the principal root, and the radical sign indicates the principal root. So the principal fourth root of 16 is written as, there's your index, so 4 radical 16. Or you could say the fourth root of 16. The principal fourth root of 16 is 2 because the 4 root 16 is equal to 4 root 2 to the fourth. The other fourth root is written as this, negative 4 root 16, which equals negative 2. Alright, let's go back through and let's kind of finish things out. Now I'm going to talk to you about 5 different examples, and then we're going to use a table. Since 2 to the fourth is 16 and negative 2 to the fourth is 16, both 2 and negative 2 are fourth roots of 16. But, that's the first example. But there's no real number x such that x to the fourth equals negative 16. So negative 16 has no real fourth root. And looking at another example, since negative 5 is the only number whose cube is negative 125, negative 5 is the only real cube root of negative 125. Some roots, such as the square root of 10, are irrational, but nevertheless, there is a positive square root and a negative square root. So here's a summary of how we can figure out how many roots a real number would have. Alright, where it says right here, type of number, put your radical sign and you can say this is talking about the radicand. This is the number under the root sign. Alright, the number of real nth roots when n is even. So we're talking about an even index. And then over here, number of real nth roots when n is odd. So we're talking about an odd index. So if the number underneath the root sign is positive and the index is even, there's going to be 2 real roots, a positive and a negative. Okay, we can prove that with the square root of 4. It's the same thing as plus or minus 2. Remember, what's our index if it's not given? It's a 2. So that's even, and that's a positive number. Alright? Positive number with an nth root. Alright? When with the index is odd. So let's look at the cube root of 8. Well, we can factor 8 to 2 times 4, which would be 2 times 2. So we can rewrite that as the cube root of 2 cubed. So it only has one answer, 2. So we can say 2 cubed is equal to 8. Why does negative 2 not work? Well, let's look at it. Negative 2 cubed would be negative 2 times negative 2 would be positive 4, times another negative 2 would be negative 8. So there's your example. All right. When the number underneath the radical sign or underneath the root is 0, you only have one answer each time. Okay, the number underneath the radical sign is negative, so let's look at negative 100. Well, the square root of negative 100, as we've already learned, is really going to be 10i. Well, is I real or imaginary? Imaginary. So how many real roots do we have? None. Last example. I have a negative number and an odds index. So the cube root of negative 8 we just proved, right? We said that was negative 2 times 4. Negative 2 times negative 2 times negative 2. So we could rewrite that as the cube root of negative 2 cubed, which is negative 2. So there's only one solution. So when we're using our radical sign and we're using different indexes, when the index is even and the number is positive, you have 2 roots. Everything else you have one root except for negative even, and then you have no root. Okay, moving on. So we're just going to plug through these right now. Most of these you can do in your calculator. So since 0.2 to the third power is 0.008, 0.2 is a cube root of 0.008. Alright, what's the cube root of a negative 1,000? Since negative 10 cubed is negative 1,000, negative 10 is the cube root. What's the cube root of 127? Alright, since the cube root, or since 1/3 cubed is 1/27, 1/3 is the cube root of 127. So find the fourth roots. The fourth root of 1. Well, 1 to the fourth power is 1. And negative 1 to the fourth power is 1. So you're going to have plus or minus 1, which makes sense because this is even, and that's positive. So I'm going to have 2 roots. I do. Index is even. This is negative. So there's none. There's no real roots. Again, even, positive. I know I'm going to have 2 roots. So 2/3 is the fourth root of, or 2/3 of the fourth power equals 16 over 81. Then 2/3 and negative 2/3 are fourth root. Okay, so plus or minus 2/3. Simple enough? Alright, let's look. Find the fifth roots of 0, negative 1, and 32. Okay. Well, the fifth root of 0 is going to be 0. The fifth root of negative 1 would be negative 1. The fifth root of 32, well, let's just do the math. You can plug it in your calculator, but let's prime factor it. So that would be 2 times 16. That would be 2 times 8. That would be 2 times 4. That would be 2 times 2. So how many 2's do we have prime factored? 1, 2, 3, 4, 5. So I have an index of 5, radical sign 2 to the fifth. Well, how many times does my index go into that exponent? 1 time. So 2 is the fifth root of 32. So it would be 0, negative 1, and 2. So the answer would be C. Find all the square roots of 0.001, the square root of 0.001, 0.00, actually, we'll do one more. 0.1 would be 0.01 plus or minus, because remember, even, the index is even, so the square root of that is plus or minus 0.1. The square root of negative 1 does not exist, so none. Alright, so let's look at the square root of 36 over square root of 121. Just to show you what I did is I went ahead and broke them up separately. Remember, you can do that in fractions. So it's the square root of 36 over 121. I rewrote as the square root of 36 over the square root of 121, which is 6 and 11. But since they're positive, numbers and an even index, it would be plus or minus. So we're looking for plus or minus 0.01, none, and plus or minus 6/11. So the answer is A. Moving on to the next example. Here we go. Find the cube root. Find each real number. Okay, so real number is just telling us the way it lies. So I got the cube root of -8. So let's break it down. That'd be -2 times 4, -2 times -2. So that's the cube root of -2 cubed. Since the index goes in the exponent one time, the answer is -2. So the answer to A is -2. The square root of -100. There isn't any because it's an even index and a negative number. So let's look at the next example. Find the real number root of the cube root of -27. Okay, we know we're going to have one answer. -3 times 9. -3 times -3. Again, you guys see how I prime factor it. So it's the cube root of -3 cubed. So the index is 3, the exponent is 3, so 3 goes into 3 one time, so 3 to the -3 to the first power comes out, so the answer is -3. Find the real number root of the fourth root of 81. So 81 is 9 times 9, and 9 is 3 times 3, 3 times 3, so 2, 3, 4. I could rewrite this as the fourth root of 3 to the fourth, which is 4 goes into 4 one time, which is 3. The reason it's not -3 as well, because it says the real number root. It doesn't say find all real roots. Find the real number root of the square root of 49. Square root of 49 is 7. So we shouldn't have to do any work on that one. All right, next one. All right, now notice when x equals 5, the square root of x squared is the square root of 5 squared. The square root of 25 is 5, which still equals x. However, when x equals -5, the square root of x squared is the square root of -5 squared, which is the square root of 25, which is 5, which does not equal x. So we have this. For any negative real number a, the root of n to the root of a to the nth power is the absolute value of a when n is even. Okay, that's kind of a wordy way to say it. All right, but when my index is even, and my variable, after it's been simplified, has an odd exponent, we have to add absolute value signs. So let's go through some examples. So the square root of 4x to the 6th, all right, would be 2x cubed. Well, the index of the square root's even, and my x is to an odd power, so we're going to put absolute value signs around the x. The next example, cube root of a cubed b to the 6th. Well, 3 goes into 3 one time, so I got a to the first. 3 goes into 6 twice, so b squared comes out. Well, my index is odd, so I don't need absolute value signs. Okay, now we get the fourth root, so it's an even index, so we may be using absolute value signs. X to the fourth, y to the 8th. Well, the index goes in the exponent, 4 goes into 4 one time, so there's an x. 4 goes into 8 two times, y squared. Well, the index is even, so if I have odd exponents of a variable, I need to use absolute value signs, so I would use absolute value signs around the x. Okay, moving on. Simplify the square root of 4x squared y squared. So remember, there's an index 2, so the square root of 4 is 2. 2 goes into 2 one time, so x to the first. 2 goes into 4 two times, so y squared. Well, since my index is even, any odd exponent I need to put parentheses around, or absolute value signs around. Okay, next one. Cube root of -27 c to the 6th. So the cube root of -27 where I've shown is -3. Cube root of c, 3 goes into 6 two times, so -c squared. Do not need absolute value signs because it was an odd index. Fourth root, x to the 8th, y cubed, so that'd be x. 4 goes into 8 twice, 4 goes into 12 three times. The index was even,